So some of the programs, software that can be used by facilities managers to help manage sustainability and ESG programs. We'll talk about some lab-specific issues, and then we'll talk about leading from the middle. So areas of focus for an FM are the specifications for renewable energies and energy rehabilitation. New buildings are going to be required, basically, to be 0 or plus energy buildings. That's a big ask, but that's where technology is going. That's where the demand is going. So energy efficient operations is next, monitoring the values of the equipment that you have, knowing what that data means, as opposed to just knowing you have data, but knowing what it means, and then maintaining that equipment at high levels with preventative and predictive maintenance so that it stays energy efficient. And then the recycling economy. Logs are going to have to be kept. Data is going to have to be known, what comes into the facility, what goes out of the facility, and where everything went in between, so that everything is kept and logged. Oh, there we go. So an IWMS system will help us to maintain our equipment as well as give us the data that we need to be able to manage our ESG. The facilities manager and his team know everything there is to know about the building. They know when the lights are on, when the lights are off, when water's flowing, when it shouldn't be flowing. They know when people are in the building and where they're at, how all the equipment is functioning, what the inspections are due, and all of those things. And all of that information, a lot of it's in their head, but a lot of it is in the IWMS software, which is Integrated Work Order Management System. And so that has a gold mine of data that can be dredged for ESG reporting. It can help a lot with, with the governance side of ESG by regulating and standardizing the data that comes out, as well as improving the environmental social realms that are needed. The IWMS systems can also integrate internally, so they can go into other internal software and pull data out to enhance their ability to give you information. Also externally, they can go out to your utility companies and pull in the data from your utility companies for all of your energy usage. And then they also interact with all of the building modeling systems and building management systems that you might have inside the building. Then there's the data that describes the current condition of all of the equipment. If you've got the Internet of Things involved and you've got sensors on your equipment, it'll tell you when it's overheating, it'll tell you when it's starting to wobble and vibrate a little bit. Any of those things that are out of parameter, so that you can immediately go back with your maintenance staff and fix that problem and maintain its energy efficiency. There are various places within the building that staff goes to or doesn't go to. So sensors can also be integrated into the IWMS that tells you when places were occupied, which will help you then to start to predict when you need to have HVAC running in that area, when you don't need to have it, and everything can be sensor controlled through the IWMS and the building management system. Because the last thing we want is equipment that is not running efficiently, that is out of calibration, because that is a great energy suck, and we don't want that. The U.S. Department of one of those departments, there it is. U.S. Department of Energy says that an organization can save about 20% in maintenance costs, not counting the energy costs, by maintaining the equipment to a high level. And since HVAC constitutes about 50% of the energy usage in buildings, that's a big thing to consider when maintaining your buildings. So with your data, you have to have a foundation, you have to have a baseline. You have to know where you're coming from and what your usage is in the workplace to extrapolate that data and understand what its meaning is. Went one too fast. Go back. So in a laboratory specifically, as I mentioned, they are just energy black holes. There is just electric equipment all over the place running tests on medical tests and medical specimens. The labs have to have negative air pressure, so you've got to have a fan taking more air out than is coming in slightly to maintain that pressure. You cannot use recirculating air in a laboratory. So 100% outside air is coming in and being cooled or heated to maintain a 72-degree temperature. Try to make that sustainable. It's difficult. Something that we were looking at is using the return air from the clean areas of the building, the office areas that are not laboratories, and splitting that. So some of that goes into the laboratory HVAC system, and you can recirculate that because it's not the lab air, and helping to mitigate some of that extreme temperature heating and cooling by bringing in 100% outside air. Studies need to be done, looked and see, the cost of changing your duct work and all of that fun stuff to get that taken care of. So it's something to be thought about. Another thing we were looking at is we've got a 6,000-gallon nitrogen tank sitting outside. And nitrogen, the lines out of the tank and into the building, ice up because nitrogen's cold. Like lots of ice. So it's something we had thought of and haven't pursued yet, but probably will soon, is running coolant coils, wrapping them around that piping and taking advantage of that ice to help to keep the building cool, because the ice actually forms greater in the summer than it does in the winter. So that's when you need your cooling. So trying to utilize some of that to gain some more efficiency. One of the other things that we had a lot of, we have 26 of them, are ULT freezers, ultra low temperature, sub 80 degrees centigrade to maintain lab samples. It's interesting. They use 3/4 of an average household's energy consumption in a day, each one of those. That's a lot of energy. But if you set the thermostat at sub 70 instead of sub 80, you can save 30% in energy consumption. And it's interesting, why do we have sub 80 freezers? Because somebody built it. It's not necessary for the samples, but somebody built it and somebody sold it, and here's the premise they sold it on. Well, if your power ever goes out, you've got 10 degrees of safety in that unit. Well, that's nice. But look at the savings, $6,000 over the lifespan of that freezer. And in actuality, because you're running it at a lower temperature, it will run less, and therefore you will get a greater lifespan out of that piece of equipment. So things like that are things that we as facilities managers have to do to think outside the box. Why? That big question, why? Why is this the way it is? Is there something else that we can do to change it to save energy? Now, with 26 of those freezers, that's a lot of money over the lifetime of those equipment. It's a lot of energy that is saved. So that is energy management and a lab in a nutshell. Any questions? Oh, we're not going there. I forgot about this. This actually, Fulia just posted this as part of a thing she posted today. I don't know if any of you follow her on LinkedIn, but I thought it was quite insightful considering what we've been going through for the last couple of days and what leadership is. A lot of us, none of us are in the C-suite, I don't think. We're all middle managers. We all have to manage those below us, but we also have to manage up. A lot of times we have to teach the C-suite what it is that needs to be done. Sometimes we have to make them think it's their idea, but that's fine too. That's part of leading up. But the point is that we as leaders need to operate with purpose, education, and foresight to be able to get our jobs done in the sustainability world. Come on, there we go. And there's my contact information.